Okay, this is the solution for the mock exam question 1. The standard problem is there's a mass, there are two springs on the left hand side, there are two dampers on the right hand side. The formula gives you the equivalent expression for the equivalent spring constant and the equivalent damping constant. Observe that the two springs are in series, so we apply the reciprocal rule and we just put in the values and then we work out the equivalent spring constant. The dampers are in parallel, so we just add them up together and we have an equivalent damping value. So at the top, that's the original problem. In the middle, that's the equivalent problem. The equivalent problem is basically a mass, a spring on the one side, a damper on the other side. This is basically the standard formula. So the standard formula is mx dot dot plus cx dot plus kx is equal to 0, divided through by the mass on both sides. So everything there's a 1 in front of the x dot dot, and then observe the second formula is given to you in your question. So you just divide it through and you see in the first line, in the second line, you have an expression for x dot dot with the zeta and omega n, and in the other one you have an expression with the c equivalent and the m equivalent. So basically from these two equations we can solve for zeta and omega n. How do we do that? We basically equate the terms that are looking the same. So basically on the equation on the right hand side, in front of the x dot dot there's 1 and there's 1. 1 is equal to 1. Leave it as is, you don't need to do anything. Look in front of the x dot. We have the 2 zeta omega n and we have a c equivalent over m equivalent. So equate these two and then we can get an expression. And likewise for the x we have an omega n squared and we have a k over m. And then basically we equate them. K equivalent over m equivalent is equal to omega n squared. Solve for the omega n, square root of k over m. We have some expression. We've already worked out the k equivalent and the c equivalent, so we've derived the omega n. Likewise for the zeta, we've equated it. We can put the stuff into the expression. We work out the zeta. The first part of the equation then asks you, please work out omega d, the damped angular frequency. It's given as omega n square root of 1 minus zeta squared. We've already worked out these expressions over here and over here. You just put it in there and that is your answer at the end of the day. This took about 10 minutes of calculations and then you've got about 8 marks. That's the end of the first part.